Wow, Ben's talking about redwoods. I've had spiritual experiences in those forests, man. I'm too far away from them, about as far away as I can get. There's a similar scenario, and we have live oaks here. That's kind of the dominant tree, and there's a place down in Georgia that you can go to these old growth forests, and you can walk. I mean, it must be miles on the trees because they sprawl their branches. Some of them go under the dunes and come out the other side. It's really an amazing thing. Study about how tomatoes forfeit their nitrogen from insects. That reminds me a little bit we were talking about last week in regards to the microbes and the freezing conditions. It's incredible. Yeah, I appreciate you. Any links or resources? I'm always interested to learn, guys.
So what he was, in case you guys aren't following along here, Ben had a comment about tomatoes eating flies as well, right? So apparently tomatoes will eat the like legs and wings off of flies or small insects. That's pretty crazy. I didn't know that.
I didn't either. I'm gonna have to read that one in a minute because I'll get consumed here. Let's see what else we got. Tomato carnivorous plant.
Oh, Ben wants to get on and talk with you.
Bring it.
Hey Ben, just so you know, you got your mic muted.
Oh, you mean literally? There he is.
Hey guys,
Hey, Ben.
That was a great talk. Thanks for all that info.
Oh, of course.
I just I've been a ranger in the redwoods, and so I've everything about plants always ties back to them for me. So it's that's amazing to hear about the live oaks. You can walk through places in the redwoods and just never touch the ground, hopping from giant hugelkultur bed to hugelkultur bed or nurse log, whatever you want to call them.
Yeah, that's fantastic, man. Where do you live?
I live just I don't know if you know where 101 and 199, the highways that go through the redwoods, basically just south of the Oregon border.
Okay.
Oregon-California border, outside Jed Smith State Park, and it's the highest biomass place on earth. So it's we're about 100 inches of rain since October though. So
you damned if you do, damned if you don't out there with the water, right?
Yeah, and actually, I guess you're probably at a similar. You're zone 8-ish or something. We're zone 9, so yeah. I bet you have some of the same issues. At least the closest I can think of in terms of climate analogs. Yeah. Where I've been basically trying to keep my soil alive with Bokashi, and I have ducks that I allow to go over and graze over things. But do you have experience?
I lost your audio there. Experience with Bokashi, is that what you're asking?
Yeah, in terms of, I guess, like foliar sprays, or what's the best way? What are ways that you've approached using it, or if you have caveats, like places where it's not going to be as effective as you'd think?
Well, Bokashi is a good product, or is a good concept. It doesn't have to be a product, but it's anaerobic, right? So it's typically used more for nutrient cycling than for building a food web. I mean, in a literal sense, and there are some facultative microbes that can be both anaerobic and aerobic. So again, trying to compartmentalize nature, right? But typically, anaerobic species of microbes don't really subsist in the soil for long periods of time unless they're facultative. So, the best applications that I know are to use it like to make a comfrey tea or a nettle tea, or something that you're looking over a 5 to 7 day period to extract the fertility from in a very aggressive way in order to use it proactively. So you see a lot of indoor growers doing it these days. And that somewhat makes sense because they're looking for the nutrient availability. They're growing the plant. They're not setting up a food web in a container, and then most of them are throwing the soil away at the end of the grow, right? So What they're thinking about doing is how to get the most out of what's there rather than having to throw it away at the end. And in that respect, Bokashi makes complete sense. It would also make sense, like, trying to recycle dog waste or something like that, where you or like in a chicken coop where you're trying to keep an odor down, or kind of cycle everything. But what you don't want to do is assume that by using an anaerobic product like that, that you're growing the soil's capacity to be soil, right? Which doesn't at all make it negative. It just means it's a great complement too, right? You can use them
I've applied it after doing chop and drop as a way to try to help facilitate that breakdown. And then also indoors, I've used it after applying, say, a dry organic fertilizer mix. It'll add and it'll get that stuff cooking. And it seems to be, but it makes sense that you explained why it works in a way that I didn't quite understand.
Yeah, it doesn't need oxygen, I mean, and so it's kind of an interesting, it helps me think about it too. It's like, are you familiar with biodynamic agriculture?
To a certain extent, yeah.
So it's kind of an irony of composting is most people are trying to see how fast they can finish it. The cliche of like good things come to those who wait is very real. The reason biodynamic compost, outside of other aspects of conversation, that one of the reasons it's so beneficial is because you don't turn biodynamic compost. You typically have a static approach, and it might take 6 to 8 months to make it in mounds. But what it does is it challenges the facultative strength of the scenario. So if you've got microbes, organic matter and microbes present, and you're turning it twice a week, you're creating a very weak biological environment. Because you're not giving the microbe, and it's like waiting on your kid hand and foot till they're 30, right? They're just fat and lazy. They don't have any life experience. So, and it's a cool conversation. It's also
you're not allowing succession. Right?
Yeah, it's like not hardening off a plant,
So in the redwoods, they have the highest biomass on Earth, and I speculate a large part of that, on top of the climate, is that they have such slow decomposition due to the tannins in the redwood that take as long as the tree takes to grow, so 2,000 years. Right. And so it's the slowest form of decomposition you can get, but it retains nitrogen more efficiently than any other. And as the highest biodiversity in the soil is one thing I've read about the redwood forest, because of that challenge that it's kind of like exactly what you're saying, is they are going through the ultimate challenge for the ultimate reward.
Right. You want the microbe to ferment and then go back and forth, and have to generate the environment that it needs to finish versus just making it easy, which also, if you take it a step further, kind of, it's a cool conversation. It's really difficult to measure the ability of microbes, right? It's like somebody looking at us through a microscope and you're the best soccer player on earth. And how do we know that? You know what I mean? So you kind of lose the literal thread, which means you lose 99% of people. But the reality is that, most of the biological products on the market, if you can name the microbes in the product, it's extremely limited. We know 5% of bacteria and 10% of fungi. So what they've done is taken microbes we know are beneficial, put them in a petri dish in a lab with abundant food source, no predators, no challenge, and grown them beyond a natural balance and brought them together in the end in the product. And none of the microbes know each other, and you got to kind of personify it, but you're kind of picking up what I'm putting down.
Yeah, like having giraffes next to wild or wolves or something like that.
Yeah, I mean, you can come up with your own analogy, exactly, but it's life experience is a really good way to talk about it.
They are co-adapted.
It's definitely measurable in the plant growth. How you can proactively prove that to somebody is anybody's guess.
What would be, I guess I've done this in as ethical way as I possibly can, but when I go for a hike, sometimes I'll grab a little handful of duff and I'll put that in my slow compost pile. Is there ways that you would try to keep as much diversity in your pile as you can? Just keep it cool, I guess, slow and low. And
well, I mean, you don't really need to engineer the temperature. What you're doing is probably what I would suggest. Go out, scratch the forest floor. It's unadulterated. Frankly, if you can get, 5 of your buddies' compost, some worm castings, a compost tea recipe, not to say you have to, but frankly, microbes self-organize, which for me simplifies the whole conversation. It's not about what microbe to use where in terms of the food web. Maybe it is for a disease application or something like that. But in a food web concept, you want to bring as many sources together as possible and then, let the microbes sort it out. It's kind of like the mycorrhizae. If it's not needed, it's going to get eaten. If it is, then it's going to grow. So if you're applying a fungal dominant tea into a turf application that needs bacterial dominance, it's not like you're working against the system. You're just going to have a lot of fungi dying that aren't needed. for example.
Mm-hmm. Oh yeah.
So that's kind of how we set up our compost tea recipe. Earth compound is biodynamic compost from a farm, organic compost from a farm, worm castings, archaea, and then we influence that with the biodynamic preps. And the spirit of it is to bring as many viable sources of known diverse microbes together into a product so that it applies to every situation. But every single time, if you can get them locally and you have the ability to go out and grab some of what you're doing, just you got it right under your feet, man. You know, it's in the forest. So
yeah, it's beautiful.
you do that. Yeah.
Yeah. Well, thank you very much. Yeah. I could talk. Yeah. I feel like I could learn from you for hours, man.
Well, let's keep doing it, man. I appreciate you being here.
Yeah. I guess actually, do you have any experience with using duck pond water? I use it with great success, but I don't have any scientific seems like pretty little scientific literature about it.
It's a duckwaponic system, right?
Yeah, exactly.
Yeah, I mean, the bottom line is your plants like it or not. And if you've got a highly fertile environment, which it sounds like you're, exactly where you need to be in that regard in terms of the microbe cycling, I would just say keep doing what you're doing and forget the science. But one anecdote that I would give you is that diversity, not to say you're not accomplishing it, because it sounds like you are, is one of the limitations of aquaponic growing. Typically, you set the system up, the fish start bringing the waste stream, and then we just wait on what happens to be in the rocks or the growing media that you set up or in the air. And it takes a long time for it to get up to speed, and it's extremely limited in diversity versus taking a balanced, diverse compost tea recipe and adding it proactively. Same thing happens in composting. People take their food waste and their yard waste, their landscapes are completely dead and destroyed through development and chemicals. And then they put a cup of their garden soil in their compost pile like they're told on Composting 101 online, and there's nothing alive in it. So they're just kind of oxidizing the organic matter. There's no heat buildup. They're not making humus. They're making mulch. And then people use it and they get frustrated and compost doesn't work, and they're just using the name, not the material, and that's a lot of where this kind of stuff makes sense, is if you can think about that, man, I can't just put the ingredients to make bread together and hope that it turns in. I always say try drinking a beer without yeast, you just put the ingredients together and microbes get important really quick, but that deliberate act is something that, unfortunately we have to be conscious of based on how we've operated for a long time here.
Yeah. I guess, is there a point where you see diminishing returns in compost tea applications, or what? Like, is there a step where you start to the next step, I guess, where you start to think more?
I would say so. I mean, so like if I'm consulting in a situation starting from scratch, the assumption that I need to make is that it's dead, because most of the time it is, and there's no way to look at it unless you pay $250 for a biological test. And my take on that is don't spend that money, spray it with tea, get the benefit, check the box knowledgeably, because that's what you'll do when you determine it's deficient anyway, right? So, from that perspective, I'd say, weekly to monthly applications, at least 20 gallons to an acre for 2 seasons is what I say around me. And we've got really poor soil with a lot of sand. So if you've got a highly fertile environment, it may be less than that. But within that framework, yes, there is a point in which the soil takes over for you in the way it's supposed to. And the analogy there of building a neighborhood and the microbes being the construction workers and the organic minerals and fertilizers being the building materials is really apt. You can't bring, 1 million people to a job site and build a neighborhood. You can't spray tea once. Because it's, some people, when they start visualizing microbes, they're like, wow, all I got to do is unleash the hounds and spray the microbes and they go fix everything. The reality is the majority of what you're spraying initially in an immature environment is dying. It's like the front lines in a war, So you got to be consistent. I personally think that the consistency of the application is more important than the amount that you're applying, which is a different way of conceptualizing microbes versus fertilizer. Because fertilizer is inert. If you don't add enough, it doesn't work. If you add too much, it burns the plant. Microbes self-organize and they're alive. Which incidentally, to the point of diminishing return, one of the things that's glossed over in the compost tea conversation is the fact that microbes make perfect plant food. So the very act of brewing the tea, if you could remove all the microbes from the tea, it's still an extremely valuable fertilization. And then you get into, well, are all my elements there? And frankly, without the ability to soil test trace elements, you could get into a different posture of approaching that, maybe without microbes. And it's an interesting question to there's actually a test. It's called a Solvita test. And it's you can buy it for like $20 from Woods End in Massachusetts, and it's a respiration test for microbes. So it's really cool in terms of telling yourself when compost is finished. You can actually measure the breathability of your soil. So, you know, if you had a scenario where you were starting on a new plot and you tested it and it was a 2, and you started using tea, and then, you know, 6 months later you just tested it randomly and it was an 8. Well, that's a metric of understanding that your soil is breathing better, you know?
Yeah.
Outside that, I don't really know how to draw the line, though.
Yeah. Well, it seems like something where it'd be great to have that tool. And then, I don't know, I tend to try to use those tools, and then I will observe, basically get to the point where I can observe the soil and, take a handful and get a feel for it.
Like, taste it, smell it. That's the way to do it, man.
Yeah.
Takes some getting used to, but no, I'm with you on that.
Yeah. Yeah. I've had a hard time keeping the soil out of my mouth at times.
Good man.
All right, Ben. Thank you very much.
Well, thank you very much.
Yeah.
Appreciate you sharing, Ben.
Thanks for being brave enough.
Oh, yeah.
That's awesome. Appreciate you, man.
All right.
All right. Yeah, that's awesome. Good for Ben for stepping up and being brave enough. Because we get that a lot. People are like, I'll ask questions, but I don't want to show my face.
No, Ben stepped right up, man. I love it.
All right. Looks like you got a couple Q&As going.
Cool.
Let's see. Do you want me to read them off to you?
Sure.
All right. We got Adam. Adam asks, does Evan have any experience with or opinion about the Haney soil test or Haney soil test? Forget all the benefits it's said to have, but remember it has to do with more information about living organic matter, microbial life, and other things. Prompted by Ray Archuleta, and Gabe Brown types.
You know, I've heard of that. They actually leverage the Solvita test that I mentioned, and they're trying to integrate, from what I understand, the mineral conversation with the biological, and that's totally relevant. I would say also, without deep knowledge of it in any way, shape, or form, that it makes complete sense. I mean, anybody trying to engineer a metric to understand the orientation of, you know, what I like to call the physical, mineral, biological, and energetic capacity, sort of like, you know, how does electricity, you know, proactively applying electric currents affect plant growth? I mean, go down that rabbit hole for a little while. It's amazing. So I would say, you know, without direct knowledge of what it is, that it's relevant. We did somewhat of a similar thing in our fertility management services. It's called the Soil Quality Index. And we basically just kind of, you know, arbitrarily almost, I mean, with some forethought, develop metrics of importance towards, you know, soil makeup, sand, clay, organic matter, porosity, exchange capacity, and just weighted them accordingly and created a percentage. And then basically set up a target, a method of saying, well, this is, you know, in a sandy soil, does it make sense to try to create a 20 exchange capacity? Well, I mean, that would be great, but no. I mean, you have to bring in unbelievable amounts of organic matter and clay to accomplish that. So, you know, if you're at a 4, maybe our target's at a 7 on the exchange capacity. If you're at a 1, you know, ideal in soil organic matter is around a 4%, generally speaking. Around me, I just did a soil test today. It was at 1.01 organic matter. So our goal wasn't 4%, because frankly, setting that goal would have frustrated the guy a year out if he hadn't made it, right? So we kind of have to look at it from an achievability standpoint. So we put a 2.5 on that. And then there's very real ways in which you can go about that. About 1/10 of the organic matter that you add to soil is actually going to be converted into stable organic matter as opposed to just the raw organic matter. So, you know, point I'm driving at is we set up a same sort of metric. The Soil Quality Index weights different capacities of soil to be soil, and we create a target percentage, and then we show the client where they're at. And let's say, you know, and then we actually convert that into a percentage of how much we consider ourselves able to increase the quality of that soil. So I did 2 of them from Alabama today. One of them was a Bayside site that was that 1% organic matter, and the other one was somebody who had taken more thought into what they were doing and had like a 3-4% organic matter. Same soil conditions, but they just put a bunch of lime. They had like 90% base saturation calcium, vacant and everything else. They were way out of balance, which is the point of soil testing. But the point that I'm trying to make is that in those same similar soil environments, we just created different target levels and then gave them a percentage of what to expect in terms of their ability to make it better. The person that was at 1% had an 89% increase potential, whereas the people that had already put a lot of effort into making that geographical soil better had, I think it was like 36%. And what does that mean? Not a whole lot, but it does put an analytical number on potential for people to track what they're doing. And to be honest with you, most of the soil testing that I end up doing with people who are not wanting to get into the science of soil testing, the influence of them seeing their deficiencies is probably the most profound part of it. Is I could sit there till I'm blue in the face and say, look, your soil is out of balance. It's all out of whack. It needs a bunch of help. See, your plants are growing terribly. But their mind is like, well, why isn't the grass growing? So as soon as I deliver the data and I show them that they've got a fourth of the potassium that they need, that they've been liming for 10 years and they've got so much more calcium than they ever want, and it comes from that third party entity of a lab that says this is what you got, all of a sudden they digress. They see the data, and it makes sense. I mean, that's how we're trained to think about it. So I would encourage, I'm going to look up what you're talking about there, the Haney soil test. I just did a quick web search to make sure it was what I was thinking of. I appreciate that inference, but if you have anything else to add, I'd be all ears.
All right. Ben made a comment on the flies in the tomatoes. Apparently, so the flies get stuck to their little hairs, which then I guess have some kind of acid because they dissolve the hair or the wings of the flies in the bodies. Anyway. All right, so
take another round, man.
Ben also says, any advice on how to deal with exceptionally wet winter that delays planting and soil work? Would Bokashi be a good application? And that's going to be the Northern California.
Yeah, I don't know that Bokashi is really going to help the soil structure. It's the only two ways that I know to do, three ways. One is physically, just aerating, plowing, breaking the soil up physically. Two, working with soil microbes, aerobic microbes that would grow in an aerobic tea. I mean, keep in mind the reason that people are trained to turn their compost pile is that we're encouraging the aerobic posture. And then the calcium to magnesium ratio. If you've got a lot of water retention and it's not just a geographically low area, it may be the case that you've just got a high magnesium content in your soil, and without testing, there's really no way to tell. But that's definitely true. It was back to that beach ball, bowling ball analogy that I was trying to get. I'm not sure you really followed that because it's not quite time for that with what we're talking about. But stay tuned to the soil testing module, and I think you'll get some value out of that.
Yeah, and I would also ask if it varies on whether you're doing annual plants versus perennial plants, because going anaerobic or aerobic versus anaerobic can be different, right? For like, if you want to have a field go anaerobic, that might not necessarily be good.
I'm not familiar with any crops that grow in anaerobic conditions other than like marsh grasses or mangroves or something that has changed their physiology to be able to adapt to that environment. And as nature goes, everything, there will be an adaptation. Something will take over that environment. But food crops, I'm not really familiar with any kind of anaerobic aerobic posture on perennials versus annuals. I think it more comes down to, is the soil set up so that it can breathe? You want 50% retention, 50% aeration, typically, in a general way of speaking. And that can be accounted for in a lot of different ways. But typically, you want the aerobic posture in soil microbes. If you remember what I was talking about with Ben, the Bokashi, what it's really doing is just, you can steep nettles or comfrey in a bucket for 7 days, add some Bokashi, and sometimes you can just do it based on what happens to be there. And at the end of that period, those microbes that operate without air, oxygen, have extracted the nutrition of that material to make it bioavailable. So whether you could get benefit out of that in a field, it wouldn't hurt, but I'm not sure it's going to account for the conditions you're finding in the field. The only thing that's really going to do that are the construction workers of the soil, which tend to be aerobic species.
Okay, for us guys that don't know what Bokashi is, or this would help us get into this conversation, because Ben's saying, my understanding was you're getting microbes from Bokashi that can come back from anaerobic conditions.
Well, they can operate in anaerobic conditions. So Bokashi is just a brand name. It's like EM. Like there's some Japanese guy that popularized anaerobic organisms, and he called them effective microorganisms. And it's kind of like a frisbee or a post-it note. You know, it's become something that it's not really even defined other than categorically. So Bokashi, you know, there's a brand called Bokashi, a friend of mine makes out in California. And those guys are really good dudes. If you don't know them, just look up Bokashi. I think you'll find it. But they came from the dairy industries, and his dad used these effective microorganisms, the anaerobes, the Bokashi organisms in these waste pools, because obviously they're anaerobic, right? There's no oxygen in there, and the effort of trying to aerate, you know, an acre manure pool is, you know, counterproductive. So they just put these anaerobic microbes that by definition operate outside of oxygen. And, you know, think about like extreme environments, you know, sulfur pools, or, you know, heat vents in the ocean. You know, these microbes that have adapted to operate on life processes that aren't normal to the terrestrial environment that we exist in. You know, that's kind of what generally is termed Bokashi. So you would use it to break down substances and extract nutrition and cycle the organic matter from a standpoint of nutrient extraction, rather than soil microbe reproduction, which is going to be an aerobic conversation. So if you take Bokashi, and let's assume that it's a blended anaerobic spectrum of microbes, and you then, you know, and I'm taking this from when you say come back, you know, when you say something is going to come back, you know, that you may be referencing the facultative. Facultative means the same organism can operate in both without oxygen anaerobically or with oxygen aerobically. The conditions that are at play determine its method of operation. Now, that's not all microbes. That's just very, you know, specific kind of bridge microbes. And it makes sense, because if you got an aerobic situation and no anaerobic microbe could subsist, you know, facultative organism, then when it went anaerobic, there'd be nothing there, right? So just think about it like a bridge in between. But again, I'm not familiar, and there, you know, to your point, there are outliers. There are aerobically operative microbes in Bokashi, but typically you're using them in an aerobic application, if that makes sense.
Yeah, so when you go from anaerobic to aerobic, basically those organisms, or most of the organisms, are dying, and that's why people will grab sludge off the bottom of a pond and apply that to their garden, because all those are going to be dying and then feeding the aerobics.
It's that, and also that they've done a good job extracting fertility from what falls to the bottom of the pond, right? And so it gets back into that double-edged sword. It's not just about the microbes. It's also about what the microbes have created, you know, through the brewing process or through the, you know, the fermentation process at the bottom of the ocean. So, you know, just watching Ben's thread here, there's nothing wrong with fermenting molasses and wheat bran and things like that. But just know that you're not growing the microbes in that soup that are going to be conducive to aerobic decomposition in your soil. Doesn't mean what you're doing is wrong. I mean, frankly, you could do that and support the plant growth through your fermentation just as an application. And if it's cheap, do it, you know. But the potential of aerobic concentration is taking those aerobic microbes and allowing them to build the soil into the fact that you live in a redwood forest and who adds fertilizer to it, right? It's like you can't do that unless the human applies the anaerobic extraction. And that works for you. I digress, you know. I'm a big proponent of both, you know, and what I see happen is, and I'm not saying it happened in your situation, Ben, but there's a lot of people that imagine they're inoculating a food web product aerobically by doing ferments, and they call them labs and, you know, lactobacillus and this kind of thing. And it's all nutrient extraction, and it's biological, great. But once you get those anaerobes into an aerobic posture, which is what your garden wants to be, or the plants won't be growing, then you're losing the relevance of a lot of the species you've been working on, other than the facultative organisms.
Awesome. All right, and he says it smells like Hefeweizen when he's done.
Yeah, it would. It would.
All right, we got time for one more question, guys, and that's going to be from Jamie. Jamie says, does livestock grazing have an effect on microbes? How about heavy vaccinated cattle, etc.?
Oh, man. Well, don't get me started on vaccinations. they're not helping at all. Well, I say that. It's a tough conversation because it's, there's an element of if you're running a business, and it's kind of like, the demonization of E. coli. You see on the news, they demonize that microbe, and that microbe is in animal manure. It's everywhere. And it's not E. coli's fault. It's the conditions. You're having 1,000 cows on an acre instead of 10, It's like, the conditions drive the contamination. These microbes aren't at fault. They're just expressing themselves based on the conditions, which gets into that anaerobic aerobic conversation a little bit. In terms of the pasture, though, one of the things that's kind of that I've experienced indirectly working with pasture growers through our fertility management services is that the assumption, and it's not unlike the average homeowner, that the microbes that are needed, if they've even thought about microbes, are already there. And in a lot of instances, these fields are heavily chemically treated. A lot of them are converted farmland or converted developed property in some instances where, the soil food web is not intact. The animals are manuring, but, most of the compost, if you walk into a big box store, and even like the largest compost manufacturer in the country is a horse track in Kentucky. And I've done the biological testing on it, and there are no soil microbes anywhere near it. It's just aged manure, right? And so, because, think about the gut of an animal is anaerobic. They're not soil microbes. Now, are they extracting nutrients? Absolutely. That's what allows manure to be sold. You can use the manure, and you're not really building the food web. You're just fertilizing with the solubility of the manure. And then this happens around us. It's turkey manure and pine bark, and people fill a raised bed. They grow in it the first season with what they used to doing, and they get pretty good results. And then the next season they come in and they're like, everything's dying. I don't understand. And I can almost say, well, you probably bought some of the bulk compost from Seaside Mulch or whoever it is. And, you had pretty good results last year, and this year it's falling apart. Yeah. How'd you know? And because it's just the way it works. Once the fertilization is gone, then there's nothing there to make more of it, because they've leveraged manure that was in the way they make it is they put it in these warehouses. They got concrete floors. They temperature control it. They steam it. They heat it. They turn it aggressively, and they stabilize it, right? Most of the nitrogen gets lost to the air. 80% of the air we breathe is nitrogen. So what they've created is a really high-end mulch. And it looks the part, and it plays the part. And you go through the motion, and especially season one, it can work. And then a lot of times, second season, you've lost the thread of why it's not working. It's just bad luck, But the reason for it is that there is no aerobic soil food web present to take that mulch to completion into humus to create the plant food to make the system closed. And that's where fertilization and toxic rescue chemistry and all that comes in. So once you have that framework to think about, that's what may stimulate you to reach out for a compost tea recipe or, and get that process started, and even inoculate your own compost with the compost tea or the forest floor like Ben was doing, and make your own compost and make your own tea out of it. That's the epitome, because it's free at that point, more or less. So, the bottom line is you can't assume that the manuring of acreage and pasture growing is accomplishing inoculation of the soil food web. It's a lot of pasture growers reach out to us in that capacity and get extraordinary results. One of the case studies that we'll look at in the soil testing module that we'll do in a couple of weeks was actually a pasture grower, and he was growing, instead of 5, I think it was a cow acres 800 pounds, and it was on 5 acres is the average, which is, to my mind, not a lot. He said that was the average, and he was running like 25,000 pounds on 4 acres. Which I didn't even believe his testimony, but he attributes it to food web and soil-based saturation analysis. So you can get some pretty remarkable results looking at things in this capacity.
And would you, so it'd be similar with steroids and hormones as well as antibiotics. Of course, they're kind of the opposite, right?
Well, yeah, in that you're affecting the organism. How they influence the biological flora of an animal, I'm not really sure, but it's safe to say that vaccines or antibiotics or hormones or anything of that ilk is a compensation for the unhealth of the animal, and typically that's an engineering exercise of the human. So we can either, it's a difficult, we've grown ourselves into that. I mean, when you expect to be able to buy milk the way that we buy it, mean, I don't drink milk, hadn't for years, but if you go into a 7-Eleven supermarket or something like that and buy milk at the price point you expect to buy it, you pretty much have to put 1,000 cows on an acre, you know, like economically. So what we've done is just legislated the ability to accomplish that by allowing hormones and all of these things, by allowing pasteurization. You know, pasteurization is just a nice word for irradiation that kills all of the living good and bad microbes in milk or juice or whatever it may be. And, you know, it obliterates a lot of the benefit of it, right? I mean, this is kind of, you know, how we've gotten to raw milk being legal is on one hand a travesty, and on the other somewhat understandable, you know, because if it wasn't, if we said raw milk was legal, we'd have to legislate 10 cows to the acre. You know what I mean? So it's kind of like pick your poison, and that's the difficulty of the modern world that we live in a nutshell, you know, on a lot of different levels.
Yeah, I think it definitely it is necessary when you have feedlots with, you know, tons of animals in small areas.
You want to buy orange juice 6 months later, you got to pasteurize it.
Yeah, if I'm buying raw milk, I'm buying it from the local dairy farmer who.
Boy.
Yeah, I'm not buying from the store.
I'm at the cow at that point.
Yeah.
Yeah, I'm with you on that.
All right, awesome show, man. Let's see, you're working on some potential courses with Permaethos.
Yeah.
So I imagine you'd love some ideas from these guys. If anybody wants to send them in, go ahead.
Yeah, please do. You know, anything specific, broad. I'm excited. I'm still getting my feet under me with this, but really enjoy the feedback from you guys out there. So, you know, please do keep it up. And, you know, just to plug our program here, you know, $29 a year. If you want to support us, go to the tv.permaethos.com and, you know, raise your hand there. It's certainly appreciated, and tell your friends, and, you know, we'll see you next time.
All right.
Cheers.